Chapter 2 Polynomials. Question number 1. If 1 0 of the quadratic polynomial x square plus 3x plus k is 2, then the value of k is. So here given that x equals to 2 is the root or 0 of the polynomial. Substitute this value of x in the polynomial. 2 square plus 3 into 2 plus k equals to 0. This will be 4 plus 6 plus k equals to 0. K equals to minus 10. So easy problem. K equals to minus 10. Question number 2. Given that 2 of the zeros of the cubic polynomial ax cubed plus bx square plus cx plus d are 0, the third 0 is. Let alpha, beta, gamma be the zeros of the polynomial. It gave alpha equals to beta equals to 0. We need to find the other root gamma equals to. We know that sum of the roots alpha plus beta plus gamma equals to minus b by a. So gamma equals to minus b by a. This is solution. So this would be our answer. Question number 3. If one of the zeros of the quadratic polynomial is minus 3, then the value of k. Substitute the value of minus 3 in the given polynomial and equate that to 0. K minus 1 into minus 3 whole square plus k into minus 3 plus 1 equals to 0. This is 9k minus 9 minus 3k plus 1 equals to 0. 6k minus 8 equals to 0. K equals to 8 by 6, which equals to 4 by 3. Next, question number 4. A quadratic polynomial whose zeros are minus 3 and 4 is. For this, we directly have the formula x minus alpha into x minus beta. That equals to x minus of minus 3 into x minus 4. This gives to the quadratic polynomial x square minus x minus 12. So this is our solution. In the given question, we don't have any options. Maybe this is x square minus x minus 12, option C. Next, question number 5. If the zeros of the quadratic polynomial are 2 and minus 3, then substitute the value of 2 and 3 in the polynomial and equate that to 0. We will get two equations, and if we solve those equations, we'll get the values of a and b. So substitute the value of 2. This is 2 square plus a plus 1 into x, a plus 1 into 2 plus b equals to 0. This is 4 plus 2a plus 2 plus b equals to 0. 2a plus b plus 6 equals to 0. This is equation 1, let's say. And if we substitute minus 3, it gives the equation 9 plus a plus 1 into minus 3 plus b equals to 0, which gives you minus 3a minus 3. This is minus 3 into 1 minus 3 plus 9 is plus 6 plus b equals to 0. We can equate b equals to minus 6 plus 3a. From here, equate the value of b, which is equals to minus 6 minus 2a. Minus 6 minus 2a. We'll solve these two. This will be minus 6 gets cancelled on each other. So 5a equals to 0. A equals to 0. If a equals to 0, then b will be equals to minus 6. So the answer is a equals to 0 and b equals to minus 6, option D. Next question is question number 6. The number of polynomials having zeros as minus 2 and 5. If you find the polynomial, it will be x minus of minus 2 x plus 2 into x minus 5. This gives x square minus 5x plus 2x minus 10, which is equals to x square minus 3x minus 10. So this is the polynomial we got it. Like this, if I multiply any constant for this polynomial, if I multiply 2x square minus 6x minus 20, or if I multiply 3, it becomes 3x square minus 9x minus 30, and we can generate so many polynomials like this. We can generate numerous polynomials, so it will be more than 3 polynomials. Even these polynomials will be having the same roots, they won't be getting affected. Next question number 7. Given that one of the zeros of the cubic polynomial is 0, the product of the other two zeros is. So given alpha equals to 0, we need to find beta into gamma equals to. We know that for the cubic polynomial, alpha plus beta plus gamma equals to minus b by a, and the second equation is alpha into beta plus beta into gamma plus gamma into alpha equals to c by a, and the third equation is alpha into beta into gamma, product of the roots equals to minus d by a. So out of these three equations, we will choose the second equation. If I substitute alpha equals to 0 in this equation, I'll get beta into gamma equals to minus c by a. So this is our answer, minus c by a. Next we'll move on to next question. 8th question. If one of the zeros of the cubic polynomial is minus 1, then the product of the other two zeros is. I think it's the same question. Like the same equation, alpha into beta plus beta into gamma plus gamma into alpha equals to. Here we'll be getting. So if you go to previous question, here the c by a stands for coefficient of x by coefficient of x cube. Here it is, coefficient of x is b by coefficient of x cube is 1, and we have that one of the zeros is minus 1. Let us assume that alpha equals to minus 1. Or else we'll do one thing, we'll just substitute the value of alpha directly in the equation. We will get minus 1 plus a minus b plus c equals to 0. Here you will get a minus b plus c equals to 1. So this is the one equation we got. If I substitute alpha equals to minus 1 here in this equation, it becomes minus beta plus beta gamma minus gamma equals to p. We need to find the value of beta into gamma. So beta into gamma will be equals to b plus beta plus gamma. So we got this equation as beta into gamma. If I find the sum of the roots, which is alpha plus beta plus gamma equals to minus a by 1. If alpha equals to minus 1, beta plus gamma equals to minus a. So alpha equals to minus 1. If you send this side, it becomes plus 1. In the place of beta plus gamma, we can write minus a plus 1. So beta into gamma equals to b minus a plus 1. This is our required solution. b minus a plus 1. Option A. Option A is the correct answer. So here it's kind of tricky and it's kind of lengthy. So just be careful here. Next is 9th question. So given that the zeros of the quadratic polynomial are we'll try to solve by splitting the middle term. But in the options, if you see, it didn't ask the zeros of the exact values of the zeros of the polynomial. It just asked about if they are positive or negative. So we'll apply the quadratic formula. X equals to minus b plus r minus root b square minus 4ac by 2a. That equals to minus 99 plus the value of b square is 99 square minus 4 into ac is 4 into 127 divided by 2 into 1. So this will be minus 99 plus or minus, find the square of 99. This is 891 again. So 9801. 127 into 4 gives you so it would be around square root of 9801 minus 508, which gives you 99299 by 2. So these two square roots are always negative. If you observe closer, this is minus 99 and the square root of this is less than 98 or less than 99, let's say. The value of less than 99, even if it is minus 99 plus if it is 98, let's say, we're going to get a negative value, and for the other root it's already negative. So both are negative. Option B is the correct answer. Next, 10th question. The zeros of the quadratic polynomial x square plus kx plus k. So it's like the previous problem. We'll apply the quadratic formula again. X equals to minus k plus or minus root b square is k square minus 4ac is 4k again by 2. If k equals to 1, the root will be imaginary, so there are no real roots here. We'll take the numbers k should be more than 4 or k should be more than 5. If it is 4, we'll get 0 and we're getting equal roots here. If it is 5, we'll get minus 5 plus or minus root 25 minus 20 root 5 by 2. So again here minus 5 plus root 5 by 2 comma minus 5 minus root 5 by 2. This is a negative root. Root 5 is less than minus 5. Again this is a negative value. So both are negative here. The same answer cannot. The options are cannot both be positive, cannot both be negative, are always unequal, or always equal. So the option will be A. Cannot both be negative. They can be negative actually, so this is not the answer. Or always unequal. If k equals to 4, the roots are equal. So even this is not the answer. Or always equal. Only for k equals to 4, the roots are equal. But for rest of the roots are not equal. But in all the cases, you're getting negative roots, equal roots, so cannot both be positive. Both cannot be positive because in this we always get a negative root, at least one. Next, 11th question. If the zeros of the quadratic polynomial ax square plus bx plus c are equal, then given that roots are equal. So for roots to be equal, delta discriminant should be equals to b square minus 4ac. This should be equals to 0. So b square equals to 4ac. For this to be possible, a and c should be having the same signs, or else this will be negative. If b square equals to negative of 4ac, the square root does not exist here. For this to exist, a and c should be always positive. So it happens only if the signs are same. So a and c should have the same signs. Option C. Next, 12th question. If one of the zeros of the quadratic polynomial of the form is a negative of the other, then it is. So one of the 0 is equals to the negative of another 0. This is a given condition. If you apply this, sum of the roots alpha plus beta will be equals to here minus b by a. Instead of remembering it as minus b by a, remember like coefficient of negative of coefficient of a by coefficient of x square, which is equals to minus a. So alpha equals to minus beta, so alpha plus beta tends to 0, all 0 equals to minus a. So the value of a is becoming 0 here. So our polynomial expression will be only x square plus b. This polynomial does not contain linear term and has no linear term. We have two options. Now check for the constant. The product of the roots equals to alpha into beta, which is equals to b So alpha equals to minus beta. So beta will be equals to minus, b will be equals to minus beta square, which is a negative value. So the polynomial does not contain linear term and the constant term is negative. Option 1 is the correct answer. 13th question. So here the graph didn't come actually. We'll move on to next question. Fourteenth question. The number of polynomials having zeros as 4 and 7. So we did this question already. X minus 4 into x minus 7. For this we can multiply any constant k, even though the zeros won't be changing. So we'll be getting many polynomials of this type. So answer is more than 4. 15th question. A quadratic polynomial whose zeros are minus 4 and minus 5 is. These two are the zeros of the polynomial, in the sense alpha and beta. You can just check the question and just check out the options directly. Or else x minus of minus 4 into x minus of minus 5. This will be x square plus 9x plus 20. Option B. Even if you substitute minus 4, this is 16, minus 4 into 9 is 36, plus 20, which equals to 0. So option B is satisfying. 16th question. The zeros of the polynomial x square plus 17, 50x plus 17, so 1,75,000 are. We'll apply the quadratic formula here. X should be equals to minus b plus or minus root b square minus 4ac by 2a. This gives us minus 1750 plus or minus root b square is 1750 whole square minus 4 into 1,75,000 by 2. So this is like the previous problems. This value, from this value we always get two roots, which is, out of these two roots, one will be always negative and the other will be negative in this case. Since we are applying square root of this value, it will be somehow less than the 1750 number. So minus 1750 plus less than of 1750 will give a negative number. So both the roots are negative. So both are negative. In the exam you won't get of this larger values, but you'll get the values like the previous problems. 17th question. The zeros of the quadratic polynomial are. So it's more again like the same model. Minus of minus 15 plus or minus root 15 square is 225 minus 4 into a into c. So minus 4 into 50 is 200 by 2. This is 15 plus or minus root 25 is 5 by 2, which gives you 20 by 2 comma 10 by 2. So both are positive. The zeros of the quadratic polynomial are. So you can equate this directly to 0. X will be equals to square root of 48 by 3. So whenever you apply square root, you get two values. One is positive and the other is negative. Option B. Nineteenth question. The zeros of the quadratic polynomial are. So applying the quadratic formula, 18 minus b is 18 plus or minus square root of 18 square minus 4 into 81 by 2a. This is 18 plus or minus 81 into 4 and 18 square. 18 square. This is 320 minus 320 is 0 by 2. A is 1 here. We are getting 18 by 2 as 9, common 9. So both the roots are equal and positive. Both are equal and positive. So option D. The zeros of the quadratic polynomial are. So x equals to, apply the quadratic formula again, minus b plus or minus p square minus 4p by 2. So this is the same question which appeared with the constant k, x square plus kx plus k. We did this problem already. You can just check that. So both the roots cannot be negative. Question number 21. If one of the zeros of the quadratic polynomial is minus 3, then the value of p is. Substitute the value of minus 3 in the place of x, p minus 1 to 9. Minus 3p plus 1 equals to 0. This is 9p. Minus 9 minus 3p plus 1 equals to 0. 6p equals to 8. P equals to 8 by 6. Which is 4 by 3. Question number 22. If the zeros of the quadratic polynomial ax square plus bx plus c are equal, then again discriminant equals to 0, which is b square minus 4ac equals to 0. So b square equals to 4ac. These two should be the same sign again. Option B is the correct answer. 23. If x cube plus 1 is divided by x square plus 5, then the possible degree of the quotient is. Here, if you divide the polynomial x cube plus 1 by x square plus 5, it should be always x here. The quotient is starting with the x power 1 degree. So the degree is 1 here. Then the possible degree of the quotient is. The only possible degree is the 1, which is the linear equation. So 1 is the answer. If x cube plus 11 is divided by x square minus 3, then the possible degree of remainder. So in this question he asked the remainder degree. Now the quotient degree. The dividend is x cube plus 11 and the divisor is x square minus 3. If you observe the divisor, the degree of the divisor is 2 here. Whatever the remainder we are going to get, it can't be more than this 2, isn't it? So it should be always less than 2. It can be either linear equation or it's a constant, but it can't be more than that. So it may be less than 2. Twenty-fifth question. If x power 4 plus 3x square plus 7 is divided by 3x plus 5, then the possible degrees of quotient and remainder. So it's a combination of quotient and the remainder. We're dividing with 3x plus 5. The dividend is x power 4 plus 3x square plus 7. The quotient will be of the degree 3 and the remainder should be always less than the divisor. Here the divisor is having the degree as 1, so it should be less than 1, which is 0. The quotient is having the degree 3 and the remainder as 0. Option A. 26th question. If the expression is divided by g of x and quotient is x square plus 5x plus 7, then the possible degree of g of x is. G of x is a divisor here. The quotient is x square. The starting term of the quotient is x square here. So what could be the possibility of g of x? G of x should be more than quotient, so it may start from x cube or x power 4. So x power 4 can't be the degree because x power 4 into x power 2 will give you x power 6. So x power 3 is the possibility, because when you multiply this you will be getting 5. So degree is 3. We can't take the lower values here. If I take x square, if I take x square in the divisor, then my quotient should be x cube. So this should be the case, but this thing won't be happening. So x cube is the possibility. Next, 27th question. So it's like the same question. The quotient is x square plus 5x plus 7, then the possible degree of the remainder is. So he's asking about the remainder degree now. In the previous question, we just assumed that the possibility of the divisor will be x power 3. The degree should be x power 3. And whatever the remainder we're going to get here, they should contain less than 3 degree. It can be a quadratic, linear or constant, but it should be less than 3. 28th question. What is the number of zeros that a linear polynomial has? A linear polynomial is of the form p of x equals to ax plus b. Don't get confused with the linear equations in two variables like ax plus by plus c. This is a linear polynomial. The degree is 1 here and the constant is there. So for this, only one equation, 1 0 exists, that equals to minus b by a. Only 1 0 exists for this. So option B. Twenty-ninth question. What is the number of zeros that a quadratic polynomial has? So for quadratic polynomial, ax square plus bx plus c, we have 2 zeros. Degree of a polynomial should be equals to number of zeros, or number of zeros equals to degree of the polynomial. This is important. What is the number of zeros that a cubic polynomial has? So cubic polynomial contains 3 roots. If one of the zeros of the cubic polynomial is -1, then the product of the other two zeros is. We already solved this question where we took alpha equals to -1 and we got product of roots beta into gamma equals to b minus a plus 1. So you'll get q minus b plus 1. Option C. We'll quickly go to next question. We can just see this question in the previous problems. Just in the place of P and Q, you have A and B. That's the only difference. Moving on to next question, 32nd. If one zero of the quadratic polynomial is 2, then the value of B is. So one of the zeros is 2, then the value of B is. So this is 2 square is 4 plus 6 plus B equals to 0 and B equals to -10. I think this is the first question. If one is one of the zeros of the polynomial, the value of k. So k equals to -2. If you substitute the value of 1 here, k equals to -2. 34th question. If p of x is a polynomial of at least degree 1 and p of k equals to 0, then k is known as. If p of k equals to 0, k is called as 0 of the polynomial. 0 of polynomial p of x. So it is option B, 0 of the polynomial p of x. If one of the zeros of the quadratic polynomial is -3. So the question is that if one of the zeros is -3, then find the value of k. So it's 9 into k minus 1, 9 into k minus 9, minus 3k plus 1 equals to 0, 6k equals to 8, k equals to 4 by 3. 36th question. If the zeros of the quadratic polynomial are 2 and -3, then substitute the value of 2. 2 square is 4 plus 2a plus 2 plus b equals to 0. First equation. This is 2a plus b plus 6 equals to 0. If I substitute -3, this is 9 minus 3a minus 3 plus b equals to 0. So b minus 3a plus 6 equals to 0. B equals to 3a minus 6. Here b equals to -6 minus 2a. Equating these two, -6 gets cancelled, a equals to 0. So option D is the only one where a equals to 0. In MCQs, don't spend a lot of time finding the solutions. It's only that since we already have the 4 options, just try to eliminate the options. Here a equals to 0. This is the only possibility where we have out of 4 options. So directly it's answer D. Next is 37. So the graph is not there here. We'll go next question. Zeros of a polynomial can be determined graphically. Number of zeros of a polynomial is equal to number of points where the graph of polynomial intersects x-axis, y-axis, y or the x-axis, none of these. If you understand the graphs of polynomials, for every graph, if you take any curve, any random curve, whenever we draw a curve, the curve should be touching the x-axis instead of y-axis here. So if you draw a curve like this, whatever the points we have touching the x-axis, these are our zeros of the polynomial. No matter how many points a curve touches the y-axis, we don't count these points. It's only the points which are touching the x-axis. So zeros of the polynomial is defined graphically as the points which intersects the x-axis. Option B. If graph of a polynomial does not intersect the x-axis but intersects y-axis in one point, then number of zeros of the polynomial is equal to. So here, if you take a graph where the curve is not intersecting the x-axis but intersecting the y-axis in one point, the number of zeros of the polynomial is equal to. The curve may be like this. It is just touching the y-axis at one point, it is intersecting at one point, but it is not touching the x-axis. So here there are no zeros, no solution is there here. No solution indicates no zeros of the polynomial. So we have 0 zeros of the polynomial. Option A. A polynomial of degree n as. So a polynomial of degree n as at most n zeros. Zeros of a polynomial is defined as the degree of the polynomial. This is the degree of the polynomial. For a cubic polynomial, we can have 1 0, 2 0 and 3 zeros. So 3 is the maximum limit. Similarly, for a degree of n is the maximum limit. So at most we can have n zeros. At the maximum we can have n zeros. We can have 1, 2, 3, n minus 1, n minus 2. But the maximum limit is n zeros. More than that we can't get the zeros. This is important question. If p of x equals to so there's a printing mistake over here. Let's skip this question. For the second question, p of x equals to ax square plus bx plus c. 1 0 is, so we'll just skip these questions. So till 40 it's enough. So that's all from the polynomials. So don't try to solve each and every question. Just check for the options and try to think logically and shortcuts. Don't spend a lot of time in solving the MCQs, just spend 1 or 2 minutes. We'll continue our video in the next chapter, third chapter.